So I finally got all the bits and pieces cleaned up and painted and replacement parts I needed to put this generator back together. Everything for the most part's here. The armature, if you go back and look at the teardown video, there was two different armatures. This one had larger wire in the windings, and the other one was more windings with finer wire. This one came out of the parts tractor. The other armature came out of mine, and I think this might be a 12-volt armature. I think somebody might have converted it. It's hard to say which one was original because they were both looked like they were taken apart. Although I know on our tractor it's been there since the early 80s, so this one I'm not so sure about. The generators were both the same part number. They did have the tag on them. But we're going to go with this one, try it out, and see what happens. Our field coils here, these are not new field coils. I took the two sets I had and compared them with some literature I found online measuring resistance through the coil. Also, an example, this one here. Let's see if it'll focus here. There we go. Yeah, so this one, you can see some of the insulations burn off. I took a meter and could touch it and get continuity through it. And this one measured a lot lower resistance than the other. So what I did, I cleaned these up and I enamel coated them. I did not get the proper enamel. I just used some enamel paint and dipped them. This generator is such low current, it won't get a ton of heat and not get a ton of use, so it should be fine that way. The same with the red enamel that's on this armature here. But I dipped it and then I wrapped it in tape. It's like a cloth type friction tape. So obviously replaced the wires and leads going to it. Replaced our binding post there. I have a binding post for the brush also, a new one. And a new bearing. Everything else is pretty much cleaned up for the most part. I'm even going to use the brushes I have because they're decent. Alright, so very first step, move this stuff out of the way. I want to install my field coils into the housing here. If you look on here, you got A for armature, F for field. So when we install it, this lug is going to go through the field side. Got to install these center pieces. I'm not sure what these are called actually. Coil goes around them. Then we have screws that'll come in from the outside and attach it. So I got to make sure this is clocked right because it could go a couple ways, but all our connections are on this side, so as long as our wires are over here, we're good. I'm just going to put these in with a flathead screwdriver now, hand tight. I will impact them down and torque them properly after I'm done with all of this. But this will get us where we need to go to finish this step anyway. Everything here I sandblasted, then primed and painted. Alright. Let me show you these posts, by the way. These are pretty cheap. I got these off of eBay. I think I paid $5 for the pair, but soldered new wire in behind it. I was gonna kind of go with what I had and possibly 3D print a insulator at ABS, and these were cheap enough and probably a lot better, so went with it. So we have a fiber washer for insulation, then a metal washer, and a nut. It's hard to say how tight to put this. I'm sure there's an actual torque spec for it, but if I put it too tight I could break it. See if this will focus here. If you look on the inside, I had enough wire where I looped it down, so I have a little extra in case I happen to break it off or do something and need that extra. Alright, so next one, we're going to install this. This extra one here off the field coil, that goes onto the third brush, but we'll go over that later. So this will mount to a brush through here. This one is going to mount to a brush right about there. And those are two connections you make after you get the brush assembly on. With it all black, it's hard to see in there, but that's what we look like at the moment. I'm going the cheap route on this with a budget build, just to try it out, but you can get new field coils, new armature, and new everything for this for, I don't know, the cheapest I've seen them is about 125 bucks will get you an armature and a field coil, but they do go up from there. Alright, set that to the side for now. Next up is our brush assembly. So something else to test, if you want to make sure this is not shorted, these two posts here with the insulator around them. Now you notice mine's got a little crack in it, but that's just where it sticks up. It's fine inside of the housing, and it's fitting tight, so we're good there. But take your multimeter and test for continuity between here and the ground. These should not make contact to this housing. These can, it's okay, because they're a brush that's grounded anyway by this part here. Alright, first step, we'll put the two brush holders on this one. All three of the brush holders are the same. So we're going to put the holders on this back plate. And they go like this, essentially. It's a little trickier than that because we have to cram this spring in. So on this spring, this long tab presses against that side of the housing. And this one you see in the bottom here, we got to flip around and hook on this small post. And I'm going to use needle nose for that. And it hit my finger. Awesome. There we go. When you're all set, should look like that. So in this brush, it goes all the way down to that insulator, so that keeps it from going down further. This one, the spring in a groove there actually stops it from lifting or dropping. Next up is our third brush. Third brush is on a ring that mounts here. But this one is the same way. These two posts are insulated from this ring. So you can test those with the DVOM, make sure you don't have continuity there. But the brush sits on it exactly the same. Alright. Now this brush installs around here, but you got to get it under that clip that's holding this ground. So you come in at an angle, drop it down, and it sits like that. What holds this one in place, there's a screw and a little clamp that goes through. So this is going to sit on top. And the screw goes in from the back. When this sits like that, you can loosen the screw from the outside and pivot this brush assembly. Let me loosen it some so you can see it move. And you can shift it. This is to vary the voltage. This system does not have a voltage regulator, it just has a cutout relay. And you can vary the voltage it's charging. So if it's overcharging, you back it off away from this brush to drop the voltage. And if you want to increase the voltage, you move it closer. And you can put a meter on it and have it snug enough that it doesn't move on its own, and adjust it a little, crank it up, and measure it each time. Next, we're going to put brushes in here. I have a few to choose from. They're all about the same length, so I'm going for the ones that are squared off better, which would be these three. Now on this third brush, the way it was wired on this one, and it's probably not the right way, but there's probably supposed to be a screw there, but I didn't have one, so it had this wire attached to the brush mount, like so. I think it might originally went on this hole in the end, but since there's a ground, it's not in the way at all anyway. Okay, so I will press this brush back, and I'm just going to snug it a little bit. I'm not going to tighten it up tight just yet, because what I want to do when I get all these in, these might not be worn exactly square, so I might have to pivot them a little bit so it will sit flat on the commutator. But we'll get them all in first and then worry about that. Also, if you notice, there's a little bit of rounded taper to the wear, and I have it where when it's about right, it's sitting flat. If I rotated it over the other direction, it would not sit flat against it. Since these brushes are already worn in, they're about the right shape. We'll just temporarily set this armature in here. See how they're laying against it. Alright, so I'm just making sure it is sitting square. Make sure it's sitting perfectly flat, not at an angle or anything. And then tightening it down. I do want to use a little bit of emery cloth to seat in these brushes, so pull this out. I'll show you what I mean by that. I don't know if this is the right way to do this. They probably have some special tool for it, but this is the way I've done it for years. I also have This is 180 grit, but it's used. I've used it on the lathe, so it's not very aggressive. I don't want it to be too aggressive. So put a 2-piece tape on it. And wrap it around. This way we'll sand it to the right shape. And help a lot with the seating process. Doesn't take much. Probably it. There's a bushing on the back. And this one's in good shape. There's no slack, so I did not bother replacing it. You're supposed to oil it. Pop this oiler open. Fill it with oil. There's a little chamber here that holds oil. Normally on this rear bushing here, there's a piece of felt. There's a big hole there, and the felt would go down into this little reservoir, and you'd fill it with oil. I do not have a piece of felt for that, and most bushings these days you grease up and it's good to go for a long time. So I am going to do that. One thing I will do though is I'll fill this reservoir with the grease before I put a cap on the back. On this back cover, I'm going to put a little bit of RTV around the edge so it does not leak out. It will not take much of this. Alright, I had to clean up screws for this real quick. I forgot about those. So a lot of these screws I'm putting in here I haven't painted or anything. I'll touch up after it's all put together. So these I just wire wheeled off real quick and cleaned them. Uh-oh, looks like I missed a piece of crud there. All mounted. Grease in there, I'll redistribute a little better in a minute. Alright, this part's done. Let's move on to the front housing. The front housing had a bearing originally that you would oil. The bearing that was in here was actually a sealed bearing, but it wasn't very good. It made some noise when it felt rough when I spun it. Before we install this bearing, there is a spacer that goes in. You see this little tab. It goes in a matching groove here. So it's going to sit like that. Bearing goes on top of it. And we have a retainer plate. Alright, so we get to put all this back together. So the armature here, I cleaned it up. I checked continuity to ground, make sure there's no short to ground. The armature windings are less than an ohm. I have a bench DVOM that will measure down to 4 decimal places on the resistance, and basically what I did is measured to ground, then measured across, and just made sure they were all the same. So it doesn't seem like anything is shorted together, and nothing is shorted to ground, so I'm going to assume this is good. The proper way to do this would be put it on a growler and you'd be able to tell if you had a short. But I do not have an armature growler, so I'm going to go with it and see how it works. I did run this generator as a motor, putting power to it before I took it apart, see if it spun. It spun smooth and seemed to be fine there. So we'll try that again once we get it back together. Okay, I'm going to make sure I distribute grease properly here. Best I can. Still a few air pockets in that reservoir, so if this pushes the grease back, it'll just push it into there. I'm not sure if the grease will get this high though, but okay. So we just move these brushes out one at a time. Alright, if you look on this, the back of this center section, there is a hole here. And on this plate, there's a dowel. That dowel engages that hole. And that would clock it correctly. So this does not fit. What do we learn from this? Either these aren't tight enough yet, and I'm not pulling those shoes in, or pulling those field coils in far enough yet, or I have too much paint on parts and I'd have to pull the paint off of the mating surface of that. Alright, it fits, edit out that part. Okay. Yeah, with that where it needs to be, it clears all the wires and the top half of the field coil, so we're good there. Makes this part a little more interesting, but not impossible. Okay. If you look in there, you'll see how this armature goes too deep and it starts to contact the brushes. Well, this front plate is actually what holds the armature in place and controls the thrust and the end play. So part of it bolts against this bearing here, and then when you tighten the pulley down, it won't move anymore, and it should set it in the right position. So we'll double check that. If it does not set it in the right position, I might need a washer here. I have a washer that looks, a spacer that looks just like that, but I think it came off the other armature. What I'm going to do at the moment, I want to just start these screws. Keep it from flying apart. And I want to go ahead and put the front pulley on and make sure that spacing is correct. Okay. So I'm trying to move this wire that runs from one field coil to the other around the bolt I'm putting through. I need to look in there and make sure it's not going to contact the armature at all when I get to that point. So we have this spacer that goes over. Actually, probably go ahead and tighten this down. So it's not totally tight, but just snug. The armature does not turn because it's pressed too far that way, so I believe if I tighten this down, I'll get what I need. I need a key. Forgot to clean that part too, so I bet it's in here somewhere. I did not clean up the key, but probably not too big a deal for this. Lock washer and a nut. I need to go get a socket for that real quick. Okay. It's a little notchy. And what's happening here, I think, see, it feels like the armature's hitting the field coils. Let me try snugging them down a little more. There we go. All right. So if I had to do this again, I would probably make sure there's not any paint between the center section and the housing, because I bet that's what did it. Alright. The noise you hear there is the brushes squeaking a little because they haven't seated in. Okay. So this wire belongs on this brush here. It looks like it's kind of in the way of that darn bolt. Wonder if I could twist it around here. These are not the right ends. Generally, you got ones that sit at 90 degrees. But it looks like it'll work. Hopefully I don't drop this in the works here. Oops, almost did. There we go. Okay, that's not touching that. Not touching that bolt at all, so we're good there. This is the adjustable one anyway, so I'll have it over here. Yeah, so the third adjustable brush is the one the field coil goes to. And you decrease the voltage by moving it this way. You increase the voltage by moving it closer to the other brush. And I'll start off with it over there at some point. Get this one on here. This brush goes to the armature lug. Alright, I want to make sure none of these wires are contacting anything that moves. They do not seem to be. This one over here is fine for that brush. This one is not. I feel like this wire is too stiff. Yeah, this one's too stiff. It's limiting this brush's travel. So I'm going to have to pull out this lug and desolder that and put in a wire that's more flexible. But everything else seems to be great. Got plenty of movement. I think what happened here, this wire is really stiff. I think when I soldered it, it wicked the solder into it because it was really flexible, but it's pretty stiff there. See if I could do this without taking everything apart. That would be awesome. I think it'll work. Yes. That was cool. Okay. Yeah, this wire is really stiff except for right in the middle, which means my solder, I put too much solder on it and it wicked through the wire and made it stiff. So something I want to do real quick before I do this. It's almost 11 p.m. so I'm not going to do that today. I will finish this video up tomorrow. But just because I wanted to see this thing work. Now with this motor, you apply power to the field and it'll go through the third brush through the armature. So if I put 12 volts here, I can test my setup. See if this thing actually works right now. All right. Pulley looks a little bent, but probably not enough to worry about. And that's normal. That's my button resetting on the jump start box. That's what we got so far. I'll come back tomorrow and we'll finish this thing up. And if everything goes well, I will hook it to a motor and see what kind of output we got. In the last part of this video, I had to remove this post for the armature and install a more flexible wire so this brush can move. So we did that. We used some of this really fine strand braided twisted copper wire, so it's good and flexible. That part of this video is actually 3 months ago. I kind of put this on the back burner. So now that we have it all together, there's a couple tests I want to do. So in the previous section of the video, we ran it like an electric motor to prove it actually works. That's a pretty good test. If it runs smooth, doesn't stop, technically your fields and your armature are good. Now there still could be some, one shorted winding or something in the armature, but I can't test that without a growler, and I do not have one, so we're going to go with this. I could probably test it on an oscilloscope. Next, I'm going to actually run this with an electric motor and see if it's a generator, see if it works. So let me get that set up and then we'll do it. So here's my setup. Electric motor running the generator, which is going to run it at a little bit higher RPM than the engine would run it at, so we'll probably get a little higher voltage. I have a meter on the armature lead, which is the output, and on ground. I don't want to ground it to my painted surface here, so this particular brush actually goes straight to ground, so I'm just grabbing it on that brush holder. Got a light bulb in line with the meter just so we can see it working under a little bit of load. And what should happen here, I take our field and ground it, and we should get our voltage, whatever this is going to put out. Now normally you'd have to polarize this generator, but technically 3 months ago on the first half of this video, when I ran it as an electric motor, I polarized it. So we'll see if that's holding. If I touch this to ground and we do not get any charge, then I'll need to polarize it and see, but it should be enough there to do it. So I'm going to get this turned on and ready to go. I don't know how loud this is going to be, if this is going to interfere with the microphone. This is a noise canceling headset, and it seems to cancel out all my shop fans and stuff, so it's probably okay. Now we're running, it's actually showing about a volt, but that's not much. We don't have any field yet, except whatever's there. So when I ground this field, we should get power. Showing 21 volts. There we go, 19 volts. This thing is kicking. At 19 volts under load right now, but we're spinning a lot faster than the tractor would normally spin it. Hey, I just popped my breaker for the extension cord I'm using to run this. But proof of concept is there, and it's working, so we're good to go. So here's the one thing I do not know. If you watch my generator teardown video, there is some weird stuff. Like, I had 2 different generators. Both of them look, well, they were both off the same year tractor. The serial numbers matched what they were supposed to be, but the armatures were different. Both of them were apart before. It looks like both of them were pieced together. And I picked the best armature I had. I have a feeling that the armature I used was a 12-volt armature. Maybe they converted it or something, but this is the armature I didn't use because it was pretty crusty and looked burned up and had a couple shorts in it, but it was really fine windings compared to the other one. The other one's really coarse windings. So that could be why I have more voltage. I'm going to test this at tractor speed on the engine and determine from there what I'm going to do. I still may need to upgrade the fields to 12-volt fields, but this will get me going for now, get me running, and we'll see how it goes on the tractor.